Hello, everyone. Welcome to the December 2012 Professor Messer Network Plus Study Group. We do this group every month, and I'm finally here at the end of the year. The big holidays are over. We're now waiting for New Year's to arrive. It's a great time of the year to take a step back, relax, maybe go through some things that might help you pass your Network Plus certification in the new year. Now, for those of you that are watching live, I have a chat room that I'm watching on Ustream. So if you're typing in there, I can see all of you in there. Also on the Professor Messer website, at the bottom of the page is the chat that we have there 24 hours a day, 7 days a week. Whenever you have any questions or you want to find people that are also studying for their certifications, it's a great place to go. And I have opened up a new study group chat room on that page. So you can always go to Live Network Plus Study Group at the bottom. And while we're live, you'll be able to talk to me directly in there as well. Well, we've got a lot to go through. I got a lot of your questions this month. But before we do that, I want to thank you because we are not able to do these study groups without your help. And for those of you that come to the website and watch the videos and go through all of your certifications, I cannot thank you enough. It has been a fantastic year, and it helps us keep all of these things going. It keeps the website running. It keeps our live stream able to continue. All the cameras are working. All the audio is working, those types of things. So it is one of those nice things to have, and it's thanks to you. There's also people that have decided that they need access after the fact as well. They want to take these videos with them. They need MP3 versions. They would like copies of all the slides and PDF, and you can get all of that if you visit professormesser.com/download network plus. You'll be able to see that as well. So this is one of these things that helps keep everything going. It's a great ecosystem that we have here, and I thank you very much for that. It has indeed been a fantastic year. One of the questions we got this month is one that comes up quite a bit, because if you already have an A+ certification, if you already have a Network Plus certification, you may want to renew that certification, and there are continuing education units that you can get from CompTIA. This live event and the replay, I would imagine, also counts towards some of those continuing education credits. If you go to the continuing education FAQ out on the CompTIA website, you'll be able to see this. There is, in this particular case, for A+, you can have up to 4 CEUs that are available to be used for renewal. You have 6 CEUs for Network Plus just by watching seminars, webinars, conferences, those types of things. There's many other tasks that you can perform to also gain those CEUs. If you want to know more about renewing your certification once you have it, you can search on the Google machine for CompTIA certification renewal, and there is a FAQ. Maybe that's a good term to use as well. And that frequently asked questions document pretty much covers the bases. Everything you probably need to know is in there. And if you need to know more, you can, of course, contact CompTIA directly. They're very good at answering questions and getting back to you on the emails as well. As I mentioned, we got a lot of questions. I spent yesterday seeing how today is the 29th of December. I actually managed to get my tree down yesterday. And it's one of these big machines, these big devices that has like 3 big pieces. So it's a behemoth to have to worry about. And I have to bring in, extra people. That's why I have children, is they can come and help their father not break his back when he takes down the tree. So all of the tree and all the Christmas stuff is down remarkably. So I just want to make that point because that's unusual for me. So it allowed me, though, to spend some extra time on your questions. So now that my halls are officially undecked, now I can spend time going through your questions, finding out the things you want to know about, and that's what we did this month as well. Now, as I do with many of my study groups, this is not just a listen only, sit back in your chair kind of thing. I also want you to get involved. So if you're watching live, grab your mobile device, grab your iPhone, grab your Android, grab your brand new tablet that you got for the holidays, and visit this website, vot.rs, and put in 183781, or if you have a QR code reader on your device, use that QR code reader to take a snapshot of this screen in front of you, and it will take you directly to vot.rs, vote.rs without the E, and go to 183781 so you can answer the question. And don't answer this in the chat room. Don't let anybody else know. Answer the question, what type of encapsulation is common on DSL networks? It's a really good question, isn't it? We'll make it full screen here so you can actually get a good snapshot of that QR code. We're going to do a number of questions and answers throughout the Network Plus session today, and I thought this would be a good one to use. There's an encapsulation type that you commonly see on DSL networks. In fact, you really don't see this encapsulation type in many other places, and there's some reasons for that. And if you visit VOT.rs, you'll be able to answer that question along with us. I'm going to visit the VOT.rs because you have a number of options available to you. One of those options is PPPoE, one of them is PPP, one of them is IPsec, one of them is RDP. And it looks like I picked a good one. Everybody's, well, is it that one? Is it this one? Sometimes I pick the really easy questions and you guys answer it and there's one bar that's, 100 and the other bars are all 0. This one, not so easy, is it? I picked one that was a little bit off the beaten path. And if you don't deal a lot with DSL, then this is something you probably don't even run into very much, but it is something you need to know for your Network Plus certification. Looks like we've had a clear winner in the meantime. The PPPoE, let me make this a little bit bigger so those of you that are trying to find this page, VOT.rs and the number 183781. So let's break through these and see what the options are. Now, I mentioned specifically an encapsulation type used for DSL. So those digital subscriber lines, it is certainly a very popular method of gaining access to the internet in the United States. On the far right, let's look at this one first, since this has one. That's RDP. That is the remote desktop protocol. It's not really an encapsulation type at all. It's a method that you can use, a protocol that you can use to get screen sharing from a remote device. So not that one. And only one person answered that one. So we can kind of guess maybe that wasn't exactly the right answer. IPsec. IPsec certainly has an option within it to do encapsulation of data, but it is not the encapsulation type that's normally seen on DSL. IPsec, as the name implies, that IP security is one used for some encryption, generally a point-to-point or a VPN type connectivity where you want to build a tunnel and pass everything through that tunnel as encrypted data. So in the case of DSL, doesn't quite apply. Well, that brings us down to two that are very similar in their names, PPP and PPPoE. PPP is a methodology and a way of connecting over remote access. So already we're getting sort of that DSL type functionality associated with this. However, that is not the type that is used in DSL. For DSL, we took that PPP mechanism of connecting via a remote site and it did PPP over Ethernet. The PPP that we used to use and we've been using for over 20 years now is really designed for dial-up or remote access links. That's the very first time I used PPP, was to be able to take data from my computer over a modem, dial up at 56 kilobits per second and be able to transfer information. But DSL, obviously a little bit different. This is Ethernet connectivity. What the phone companies did is, because they were very familiar with PPP, is they decided, let's use exactly the same mechanism to switch people around, just like people would do if they dialed a phone, but let's do it over Ethernet. Well, you can't now people are adding on to the PPPoE. It's too late now. You can't add on to that one, but PPPoE is the right answer. That is the encapsulation type that allowed the telcos to take this technology they've been using forever and just wrap Ethernet around it. What a great idea. Then they can use the same mechanisms, the same processes. It's a familiar protocol to them. They can wrap that around the Ethernet traffic, send it through their network as PPP traffic. And on the other end, where their DSL equipment might be, they can break it back out into Ethernet and send it on its way. One of the challenges you have with this is that you're encapsulating more information around Ethernet, and you can sometimes run into problems where the Ethernet frames are too big to pass through the other devices on your network. They have to be fragmented, and in that case, that may affect the throughput and the efficiency through the network. Occasionally, you'll see options on your PPP configurations to only allow certain Ethernet sizes of frame types, change their maximum transmission unit, their MTU, to only be a certain amount. So if you're on DSL, you have probably seen somewhere, if you're reading up on how to maximize your throughput, they talk a lot about MTU, and that's one of the reasons behind that. is PPPoE encapsulation is really the question in the chat room. Okay, if we're talking OSI model, and OSI model will come up quite a bit today, and that's a really good question to ask, because one of the questions this week was about OSI in the real world. Here's an example of OSI in the real world is PPPoE. Anytime you're transporting information that is not up and there's no IP address, there is nothing at layer 3 to do anything, it's got to be below that. And we know it's not signaling, so I would probably put PPP and PPP over Ethernet at the same place you would put Ethernet, which is that layer 2 configuration. And that fits very nicely into that OSI model. We always get into these questions of OSI when we're working through those pieces. So 8 of you, absolutely correct. You really hit it. You really had the right piece there when you were working through those pieces to be able to have that right answer of the PPP over Ethernet. Good job. Let's go back to looking at other things that we have ready. We are just getting started here, and I've got a lot of data to go through, a lot of information to go through that you guys have sent me. Let's go straight to the exam content. You folks sent me a lot of great questions, and you folks have sent a lot of information directly to me in chat rooms through the month. I always write down things that I get in my email. Sometimes just questions you're asking as a comment to a video. I write those down as well. So it's a really good time to go through this. And what a great follow-up. Steve set us up very nicely in the chat room, because the next question I got, I'm not making this up, this really did come in. So perfect timing is, do you really need the OSI model in the real world? Have you ever looked at this OSI model? It's a model, so already it doesn't even sound like it's real. So already I'm wondering if it's even something that I can apply to doing things in my normal day-to-day life. The other question that comes up a lot is where things fit in the OSI model. That's a different problem entirely. Let's address the question, though, of the real-world use of OSI. You will notice in my Network Plus videos, I have an entire video of how the OSI model applies to the real world. This is a very common question. So I want to take one slide out of that and really break it down, because the videos, they go by so fast. We really don't have a lot of time to spend commenting on the details of that video. So let's talk about what we have as far as real world is concerned. Well, first, let me answer the question. We absolutely use the OSI model in the real world. We absolutely use the OSI model. Our network professionals use it every single day, multiple times a day. Extremely common to use this in networking, extremely common to use this in security, and even when you're working in operating systems. If you're managing a Microsoft environment, if you're working in virtualization, if you're managing a database, you're going to use the OSI model all the time. So I understand when you're first getting into IT and you're trying to get these concepts and wrap your head around them and figure out, what does that mean? You're wondering, is this even worth learning? Is this something that I'll even use? You will absolutely use this. And you're usually using it to talk about problems that you're seeing or talk about configurations that you would like to set up. Maybe you have a switch and you need to move traffic from one VLAN to another. And you're realizing, wow, I need to route that. I need to set up a layer 3 device to route it. I need a router somewhere. I can't just switch from one VLAN, one subnet to another. Or if I do switch from one subnet to another and do it all over layer 2, is that going to work? Because I have layer 3 addresses. Or maybe I need to set up a firewall. And my firewall not only allows me to set up layer 3 routed connections, it also allows me to set up layer 2 switch connections inside of it. It may allow me to set up layer 1 virtual connections right through it that don't even have a MAC address or an IP address. So you can see, once you get into networking, there's a lot of places where this OSI model really applies. Down at the lowest layer of the OSI model, when somebody says it looks like you have a layer 1 problem, they're really talking about the inability for a signal to get from one device to another. Whenever you have a signaling type problem, that's usually pointing to your cabling. So when somebody says, I've looked at your IP address, it's absolutely correct. I've looked at the switch, and the switch sees your MAC address or doesn't see your MAC address. Now we know where the problems are starting to rely. If the switch doesn't see you, maybe the problem is not layer 2, maybe the problem now is below that. But if you aren't able to get to the internet and you look at the switch and you see that there's a MAC address on the switch, then layer 2 is working properly, because that's where we usually see the MAC address issues at layer 2. We usually see layer 2 being that the MAC address. Sometimes you'll see this referred to, especially with the latest types of identifiers, the latest types of standards. They call them EUIs, or extended unique identifiers. Anything relating to switching happens at this layer. Whenever you go a next layer up, that's when you get into IP addresses. So if somebody has been given the wrong IP address, if they can't get an IP address, if their configuration is incorrect, then they have a layer 3 problem. If you're configuring a router to be able to route from one subnet to the other, that's happening at layer 3. And it's not that the OSI model is this static, you can't change it, it's always going to be this way. There's nuances within the OSI model, and I think that's part of what makes it a little bit confusing, is that this is not a structured, here's where it absolutely sits. This is more of a reference model we can use to describe what we're seeing to someone else, and they can interpret it also in the same way. So keep that in mind. This is indeed a model. When you get up to layer 4 and we talk about learning your TCP ports and your UDP ports, that's all the layer 4 of the OSI model, the transport layer. Everything above that tends to be how you get the application from one side to the other. So from the Network Plus perspective, most of what you will be talking about with Network Plus, most of what you'll be doing when managing your networks will be OSI layers 1 through 4. Once you get to layer 5, there's a little bit of networking in there for your encryption and your tunneling. We talked about IPsec earlier and tunneling that. Some of that, of course, is in that next layer up at layer 5. But everything above that, layer 6 and layer 7, we don't get into a lot of the networking piece. It's more of how the application server is configured. It's more of adding the application level encryption. Normally, your network team isn't configuring your SSL certificates in a web server. You know, sometimes you are, in the smaller organizations, it blends together. But when you get into some of these large organizations, there is a team responsible for routers. There's a team responsible for firewalls. There's a team responsible for the database server, a completely different group of people responsible for the web server and the encryption on it. And sometimes you aren't allowed to touch any of those pieces. If you need to change something on the web server to make the network work better, you have to go talk to those folks. And then you have to explain to them the problem. And that's where the OSI model comes in. You can tell them, here's the problem we're seeing down at the lower levels, that we could resolve this problem if we change something on the application server at layer 7. And then everybody understands exactly what you're trying to do. So don't get wrapped up in this idea that now I'm learning physical data link network transport. I'm learning all of these layers of this OSI model, and it seems overwhelming because you've never had to apply them, but you're going to start applying them very quickly. And maybe it also involves you looking at your configuration in your house. Everybody has a network connection in their home. Maybe they have a router configured, this all-in-one wireless router device. A lot of this model is now communicating and operating right through that device. We have MAC addresses that it sees. We have IP addresses that it's able to determine. We can set up port filtering on the device. So we're stepping up the OSI model. It's a nice thing to get a familiarity with. I'm going to tell you some other things as we go through the study group today that can absolutely help you understand more about what the OSI model is doing. We'll talk more about that in just a bit. So we're talking about port numbers. One of the questions that came up is there's a lot of port numbers on this test, and they're just a protocol and a port number. If you look at the requirements for the Network Plus certification, and this will not be the last time I mention this today, but if you've never downloaded the test requirements from CompTIA, you should absolutely do this because they give you an incredible amount of detail. And in that detail, they list out every single protocol that you need to know, and they list out all of the port numbers you need to know associated with those protocols. Now, the challenge with this, if you've never worked with these protocols before, you've never configured a firewall before, you've never had to, you're learning this for the first time, is it's a lot of memorization. So one of the questions I get a lot during the month is people say, what port numbers should I know and how should I learn all of these? What is the process? How do you memorize all of this? Now, unfortunately, there's no magic solution for memorizing port numbers. If we looked at a few of them, I stuck some on these pages here. Let's look at some of the TCP ports that are available. I'm just going to pull out just a single page of them. There's another page full that you have to know. So FTP, SSH, Telnet, SMTP. They all use different port numbers, and they're so close together, 20, 21, 22, 23, 25. It seems almost arbitrary that we're having to learn these numbers associated with these names. And certainly the numbers themselves and how we've connected them together at the beginning was arbitrary. We said, well, should we make SSH? Well, everybody, just so everybody knows, we're going to make the well-known port for SSH a TCP port number 22. Now, that doesn't mean that you have to run SSH over 22. These are well-known ports, but if you want anybody to be able to SSH in automatically without changing any defaults in your SSH application, then you're going to run SSH over TCP port 22. It's one of these things that's just a known standard. If you're running SSH, that's what it will run on. If somebody says we need to configure your firewall to be able to use SSH, well, I need to open a port. What port should I open? TCP 22. So it makes sense that you know these things. It's important that you know these things, but don't get too wrapped up in the idea that I've got to go through and memorize every single one of these. You do, but the process, and if you look at the entire exam for everything you need to know, the port numbers that you need to know is a small section, a small piece of a small section that's in a domain that's a member of many different knowledge domains on the exam. You might not even get a question about port numbers, but I suspect you probably get one. Probably get one, maybe you'll get two. So don't spend, if you're these people that you don't memorize well, don't spend days memorizing your port numbers, hoping for the best. Maybe put them on some flashcards and have them there. But the reality is, as you use more port numbers, as you start to gain and take advantage of these port numbers, one of the things that you'll find is that the port numbers themselves just start to come naturally. There's something that it becomes so easy to use these port numbers. And I love that piece of this, is that a lot of this just becomes completely normal. So if we look at, for instance, more TCP port numbers, I just put them all in here. There's 2 pages in the video on port numbers that are TCP port numbers. So another mix, 53, 80, 110, 143, 443. You just have to memorize them. There's no secret. There's no shortcut. These names and numbers aren't really associated with each other. Maybe HTTP and HTTPS certainly are 2 of the most used port numbers on the internet, port 80 and port 443. But unless you use them a lot, it's hard to memorize. Now, fortunately, not a lot you have to remember on the UDP side. On UDP port numbers, I think there's 3 or 4. That's about right. Only a single page. There's 5 total UDP port numbers you'd have to know. DNS, BootP, TFTP, NTP, and SMTP. But that's a lot. It's a lot of port numbers to memorize. Don't get wrapped up in it. Don't worry so much about it. Don't think that you're going to fail the test because you don't know all of these port numbers. It's okay. You're good. You might be asked 1. You might be asked 2. If you're worried so much about it, make up that time studying something else. That, I think, would be a better use of the time that you have available to you. Now, this is all of the port numbers that are asked on the CompTIA requirements document. And there are some other port numbers that are brought up later on in different sections. And whenever you get to those, you will see where I mention what port number a particular encryption protocol or authentication protocol uses. So just keep that in mind as well. A lot of good stuff there. Let's take some time now away from this idea of memorizing and have you do some tasks for me. So I have a question for you, which is, what authentication method includes something called a ticket granting service? A ticket granting service. Don't answer in the chat rooms. Don't say anything in the chat rooms. Don't type it in the chat rooms. You can simply go to vote.rs, VOT.rs, vote without the E, VOT.rs, the number 523567, or use your QR code reader. Snap a shot of that. We'll take you right to the page. So that becomes something that we can now talk about. I'm going to go to that page myself because we have some options available for knowing what that particular piece is. As soon as I find it, here it is. What authentication method includes a ticket granting service? And the options, got a few different authentications in here for being able to do this. I'm going to flip over to this mix. Here we go. Again, vote.rs 523567. Let's see. Now this is one I apparently, as I put this together, I put different technologies in here, some that would trip you up and some that haven't tripped anybody up. PKI, which is just sort of a generic method of managing certificates. That is, I got one person to bite on it. See? But look at Kerberos seems to be number 9. So your options are TACAX, Radius, Kerberos, PKI, and Microsoft CHAP. I don't think I fooled very many people with this one. I tried to put in some authentication methods that you would be familiar with, and indeed TACAX and Radius and Microsoft CHAP are some methods that are used to do authentication, especially across wide area network pieces. But you can see the bulk of everyone chose Kerberos. We're up to 11 votes on Kerberos, and indeed Kerberos is the method that includes a ticket granting service. There are the three-headed dog, Kerberos. The reason it got that name is there's 3 mechanisms that are always in use with Kerberos. One of those mechanisms is the ticket granting service. So keep in mind as you go through and have to understand how these things work. There's an entire video I have just on Kerberos. So make sure that you understand how it works. Make sure you understand all 3 heads of the dog. Make sure you understand what those heads do. And I have a nice animation in the video that describes what happens with the tickets and where they're going. There are multiple steps. And there's a lot going on under the surface of Kerberos. It's an extremely complex authentication protocol. I look at this at a very high level. That's what you'll need to know for your Network Plus exam. And that's one of the things you'll run into, the challenges you run into in working with some of those protocols and working from a Kerberos perspective. I think that's one of the things I like about the Network Plus exam is it applies in so many different places. Kerberos may be a technology that you would rarely run into. Kerberos is one of those that is all happens behind the scenes. And if you're not managing, for instance, a Microsoft Active Directory environment, Active Directory uses Kerberos extensively. But if you're just logging in and using the Microsoft environment, then you're not even going to run into situations where Kerberos is an issue. And since this was brought up, I'm going to pull up some of these slides in my presentation to give you a feel for what those are. And in fact, here we go. Here's Kerberos, the 3-headed dog of the underworld. I'll flip over so you guys can see this. There is a question in the chat room talked about what port Kerberos uses, and it talked about some of the things associated with those 3 heads. What 3 heads are we talking about? So this name comes from these 3 heads. The key distribution center runs on TCP Port 88 or UDP Port 88, depending on the implementation. So keep that in mind as you're using it. The other 2 pieces are an authentication service and a ticket granting service. We just talked about some of those pieces in there. As we're working with Kerberos and trying to understand how it works behind the scenes, if you watch that video, I go through the entire process. You'll learn everything you need to know about making Kerberos work, and it works quite nicely. That is one of the pieces I always find interesting to work with, is what happens behind the scenes. There's so much that happens under the surface on networking. And I think that's part of the piece that's so difficult sometimes to understand, is all of those things happening behind the scenes. But in a way, that's the really interesting part of networking. If you know networking, you understand how things work under the surface that nobody can usually see, then you can do practically anything. And it applies to so many aspects of IT. It applies across different environments. If you're doing databases, it absolutely applies. If you are using environments where you are doing data center management, if you're managing a server, if you're setting up a firewall, if you are managing switches, if your responsibility is wide area networks and routing, you'll be able to use all of these pieces that you learn in the Network Plus certification. I'm a really, really big fan of the Network Plus certification, if only for that aspect of it. Let's now look at another question that came through. This one, I just want to talk broadly about, because this is not a question that you're expected to know for the Network Plus certification, but it talks about why the things you're learning are so important with Network Plus. And this one is, what are the main differences between SMB and FTP? So server message block, some people also see this as CIFS, and FTP, the file transfer protocol. Now, on the face of it, they kind of do the same thing, don't they? SMB is generally what you see Windows using. There's other environments that use SMB as well, but Microsoft has really embraced SMB. They've integrated it into Windows. They've even built onto SMB and created their own extensions to the SMB protocol. SMB is a way to people think of it as a way to transfer files from one device to another. And certainly, absolutely, the primary function of SMB is that aspect. But FTP is also a way to transfer files from one device to the other. Why do we have to have multiple ways to transfer files? Why do we have to have these different mechanisms in place? What is the point and the purpose of doing these multiple different? There's other types of systems to transfer files as well. There's SFTP, a secure FTP. There's FTPS, which is also a secure method of transferring files that uses different mechanisms. There's Apple File Transfer, Apple File Protocols. There are many, many different ways to transfer files from one place to the other using many, many different application protocols. So the question here that DM sent in was a good one, is why are we doing this? What are the differences between all of these pieces? Now, we've already talked about the two major differences. SMB really wrapped around Windows. SMB is a relatively complex and very involved method of not just transferring files, but there's so much more inside of it. There's authentication mechanisms inside of it. There are different advantages you get from using SMB. We'll talk about those in a moment. Facebook and the way that it operates is a way that doesn't even use file transfers to do that. Twitter doesn't use these for file transfers, but if you're communicating to a web server or communicating to a third-party server to transfer files, FTP is very often the method that they have available for you to transfer files. Now, that's pretty interesting in itself. Why would they use FTP? So there's a couple of reasons. SMB is obviously very much a Microsoft-centric protocol these days. They certainly popularized it. They're not the only ones using it, but SMB has some nice functions. Here's an example of some of the advantages that SMB gives. Microsoft added their own extensions, and one of those extensions was when you are using SMB, take the authentication that you've already created behind the scenes. Maybe you've logged into the domain. Use that authentication when you go to a separate machine and you want to transfer a file over or put a file on that device. Now, FTP doesn't do that. FTP, you have to give credentials every time you hit a third-party device. But SMB is smart, or the way that Microsoft has used it is smart. It's able to access those devices without prompting you again for a username and password every time you go to these devices that you've already authenticated through. So that's very nice. And if you think about enterprise environments, you think about large scale, even middle to small scale businesses, isn't that a much more efficient way of managing where people can go and how they can use it? SMB has that built in. The services that are running on your Windows machine, there's a lot of things that are happening behind the scenes on your device. Those services can use that same authentication. Even they weren't the ones that logged in, but they know that you logged in and they're on that machine. They also can gain access if they would like to use it through mechanisms that are within Windows and built into SMB. So SMB, now you can see that's pretty nice. A lot of people say SMB, I don't like it. I don't like using that. I don't like using it across a wide area network. I guess there's advantages and disadvantages there certainly, but one of those big advantages is that integration into the operating system. Makes it so easy to use. FTP has its own advantages associated with it, even though it doesn't have that OS-specific hook. FTP allows us to use almost any operating system and talk to any other operating system. It is a well-known and highly refined method of communicating and transferring files because it's been around forever. There are standards, of course, based on both of these, but with FTP, the mechanisms for using FTP can be very, very little. I don't have to build a Windows machine just to transfer a file. I can just load up an FTP server. And I've got FTP servers that run in Linux. I've got FTP servers that run in Windows. I got FTP servers that run in Mac OS X, on iOS, on Android, on every other operating system you can think of, because it's a very, very easy way to set up a configuration, transfer some files very, very simply. Now, FTP, of course, has other mechanisms. It's also got power itself and being able to create directories and transfer files to it and do the authentication. Those are built into FTP. In a way, from a apples to apples comparison, probably just as functional to be able to make that file transfer, but just does it a different way. And those advantages of having that different operating system functionality and not relying on a lot of the overhead that SMB requires gives it some advantages, especially when you're talking about the internet and millions of people might be communicating to your site. You need a standard way that everybody can understand. FTP is a great standard way to do that. So that's one of those pieces that you keep in mind. And when you're looking at understanding what port numbers does FTP use, where does SMB fit in the OSI model, what port numbers can you expect those SMB protocols to use, that's why it's important to know those pieces, because when you start getting onto your network and managing those pieces and getting your file servers running and trying to confirm that your firewall is working properly, that's where you'll need to know that information. Let's go to the next question that came in this month. Can I explain how Wi-Fi speeds relate between the ISP to your local network and to the wireless adapter? SF asked this one. This is one that people get all wrapped up a lot. I went to I think it was Fry's. I was out in California on a trip, so I stopped by Fry's, which is a big box plus many, many other things. And I stopped by and looked at specifically their wireless routers. I'm in the market for a new wireless router for the studio. So I was looking at all the different options that are available today and all of the different options that are available from the different manufacturers. So there's Netgear and there's Linksys and there's D-Link and there's a ton of different models that are out there. And all of them these days are really trying to promote themselves as being the better device. And there's different levels of devices and some that are telling us that they do the 802.11n. They can do 600 megabits per second. Some are doing the new AC, 802.11 AC, so they can go into gigabit speeds and those pieces. But is that really useful for what you're trying to do? So I think it's useful to look at all of these different speeds and how they work. Now, when we start looking at network speeds that we have coming through here, you'll notice, if you look at it, these speeds are 1.5 megabit, 15 megabit, 100 megabit. There's a lot of different speeds here. Now, how does this even apply to what we're doing on our local network? Let's look at it. So DSL speeds, when we start breaking it down, 1.5 megabits per second. That's usually the best you can possibly get out of a DSL connection. And that's because of the technology, the infrastructure. Some DSLs will go up to faster speeds, different DSL technologies. In the United States, if you've got a DSL, you generally see about a megabit and a half, just because that's the way the technology works. Then if you have a cable modem, which is probably another popular way of connecting your home into the internet, you're probably getting about 15 megabits per second, sometimes more, sometimes less, but somewhere in there average. If you have a fiber connection, if you look at things like Fios, you can get faster speeds than that if you pay for them. They can have speeds in some cases up to 100 megabits and higher. And if you're in Kansas City with Google as your network internet provider, Google gives you a gig throughput to the internet. Are you kidding me? I'm just going to move to Kansas City. That's it. I've had it with my paltry 100 megabits per second business line through my cable modem provider. I want the big fast speeds. But let's look at the rest of the world. Now, we're not all getting gigabit connectivity to the internet. That allows them to do amazing things. They have huge numbers of HD channels coming in through that. They have extreme functionality. They can go back in time and look at all of these different shows on all of the different networks that are just stored for them in the cloud. It is quite remarkable. So that is the piece that I find is really, really useful in being able to work with those things. But let's look at those speeds. If I've got a local wireless configuration, for instance, my 802.11n, best case scenario on the best possible hardware is a maximum theoretical throughput of 600 megabits per second. Well, if I've got a cable modem connection, it's only 15. So my local wireless network is almost always going to be going faster than the connectivity I have to my ISP, unless you're in Kansas City. On your wired networks, and I have a wired Ethernet network in this studio, my wired Ethernet network is a gigabit network. So I'm going much, much, much faster than what I could ever possibly get. But I'm transferring a lot of local files. I'm doing things that aren't quite the normal thing. The challenge you have with these wireless networks is not really these days the throughputs as much as it is the things that can interfere with your signal. So although I can get on my 802.11n wireless network, I can get throughputs of up to 600 megabits per second until somebody starts popping popcorn. I think we've all seen this. Until somebody gets on that local telephone and they start using their cordless telephone, the old cordless telephones in the house, suddenly it's conflicting with the same frequencies. And when you get into those scenarios, your ability to get traffic from your machine to your router that can even get out to your 15 megabit per second really becomes an issue. So it's not total throughput at that point, it's interference you're getting. So wireless networking becomes an issue. And as I mentioned, your cell phone rings, other people in the chat room, you turn on a lava lamp. So I would imagine lava lamps probably have that heating element inside of them. There's lights on. It's probably not the highest made piece of equipment. So there's all kinds of radio interference that's coming out of that device, probably across the spectrum, probably interferes with everything that's in your house on a radio signal. But that's a bit of a challenge. One of the questions in the chat room, what about the adapter, the device adapter on your computer? I guess a very old computer, if you're plugged into an old PCI slot, could potentially create problems. These days, our laptops, our tablets, our computing devices don't tend to have your device adapter be your slowdown. But on your legacy devices, certainly that can be an issue. So when you're in the process of trying to figure out what should I do from a throughput perspective and from a Network Plus perspective, you may be put in the position to do exactly this. You're at a remote site. This remote site connects back to the main headquarters building over an internet connection. You've bought a cable modem connection from an internet provider local in town. And instead of sending that information in the cloud over the internet, you're going to create an IPsec tunnel between your remote site and headquarters. This is a very, very common method to be able to connect a remote site that has just a few people in it because it's so inexpensive to do it this way. So when you do that, now you have to decide what infrastructure equipment do you need. You know that your local cable modem provider is only going to give you 25 megabits per second, 50 megabits per second. And now you can start deciding, how am I going to do this then? How am I going to bring in an equipment that's not going to be so slow that it goes slower than the throughput out on your internet connectivity? Or think about local connections. Maybe they're like me and they need to transfer massive files, but just within that building. So they need gigabit connectivity perhaps in the building. All of these numbers, if you're ever in this process of mapping out and planning a network, this is what you need to do, is map out exactly the speeds from one point to the other and decide exactly the type of infrastructure equipment that you will need to make sure all of these are going to work properly. You can generally mix and match all of these. You don't tend to have much problems going from a 100 megabit per second network down to your 15 megabits over the internet because your infrastructure equipment has buffers inside of it and it sets up a communication over TCP that's waiting for acknowledgments and only going to send information after it receives an acknowledgement. So there's some advantages to the built-in protocols going over this that help us decide what type of equipment we're going to need. We can just put in what we need from a speed perspective. The protocols take care of the rest, generally speaking. It doesn't always work that way, but for the most part, it certainly works that way. These days, it certainly works that way. In the past, there have been some challenges there as well. So it's a pretty good question. Map out your speeds, see what type of infrastructure equipment you have in place. And if you're thinking that replacing your cable modem with one that will support a higher speed wireless throughput is going to get you faster internet access, that may not necessarily be the case. You need to look at all of those different scenarios. Let's have another question of the day. This question: which of these protocols, and we'll look at this, if you go to the page, you'll see which protocols, which of these protocols would be the best choice if you were going to monitor device availability and performance? You're going to actively monitor and check that. Go to vote.rs, vote without the E, vot.rs 695421, 695421, or use your QR code reader, take a snapshot. Do not answer in the chat room. Do not say the answer. Simply go to vot.rs and go to 695421. 695421, take a snapshot, look at those pieces. I put up a few different protocols. These are protocols that I've used through the years to be able to do exactly the monitoring and the analysis. And you get these types of questions also on your Network Plus exam. Some of these questions you get are asking you for the best choice. And that is really the challenge you have is best choice. Your questions that you're, the responses you have here are syslog, ICMP, NetBIOS, SNMP, and Event Viewer. So those are the ones that I put in here so that you could try to figure out what would be the best choice for monitoring, ongoing monitoring and analysis. We're constantly watching something. We're not just seeing if it's up or down. We're constantly monitoring, not just for availability, but also the performance of a particular device. Again, don't put that in the chat room. We don't want to talk about what the answers might be. But if we look at this, we can see there is sort of an overall winner here. Not really one that that really stuck out from the other pieces I put in here. I wasn't really fooling anybody. Let's step through these though, because obviously some people answered some of these others, but why would you even consider these? And some of these are a little bit tricky. For instance, syslog is a common way to take log information and send it across the network to another device. This is commonly done for log consolidation. If you're managing a network, you've probably got logs on routers, on switches. You've got logs on firewalls. There are logs in your file servers. There's logs in every single device on your network. And instead of going to every single device to look to see what's going on, you can have all those logs come back to a single place. It's very common to have terabytes of drive space set up for these log consolidation tools, and you use a common, well-known protocol, a standard protocol that all of those devices know. Your switch knows syslog. Your router knows syslog. Your Windows devices, they know syslog. Your firewall absolutely knows syslog. And you can say, please send all of your logs back to this consolidation device that also understands syslog, even though it's not a router, it's not a switch, it's not a firewall, but it knows syslog. So this is the universal translator between all of these devices that are very diverse, that are doing very different things. Their log formats are very different, but it's a standard way to transfer that all down to one place. Very, very nice one to be able to use, but it's not a mechanism for monitoring. It's not a mechanism directly for performance. You can sift through the logs and sometimes performance information would be in there, but that's not our best choice, is it? ICMP is a protocol you commonly think about to see is something up or down. I want to check availability. That's ICMP. We can use an aspect of ICMP that is an echo request and an echo reply. We usually call that ping. So we use the ping command to send an ICMP echo request. That device hopefully will receive that request and send an ICMP echo reply. But that's a one-time thing. Sometimes you can integrate that into a device so that you can at least get an ICMP request reply every minute so you can see when something goes down. That's not really giving you very good performance statistics either, but it's just telling you if something's up or down. I need to know how much disk space is available in a device. I need to know how many CPU cycles are being used on that router or that firewall or that file server at any particular time. I need to monitor that and get a performance breakdown of those pieces, and I can't do that with ICMP. Certainly valuable in what it does. NetBIOS is a protocol, does something completely different, doesn't even apply here. And Event Viewer obviously is a Windows executable, Windows program you would use to view the logs that are on a Windows device. And SNMP is the one that everybody chose. 16 at least of you chose SNMP, and that's because the Simple Network Management Protocol is exactly designed to do this. It sends a request to a server and says, please tell me what your CPU cycles are right now. Tell me how much memory is in use. Tell me how much disk space in use. And that device will reply back with the answers to those things. And then you can start tracking that over time. That is exactly what is used in practically everyone's environment to monitor devices and gain availability and performance details, certainly monitoring that over a short period of time and long period of time as well. One of the questions in the chat room, if we go back to ICMP, is how about this ICMP can tell us a little bit about performance. It tells us time to live. It tells us response time. If you ever do a ping, it tells you how long something took to get out to another site. And I think we do run into that quite a bit when we're working with those pieces. Let me bring up one of these, and we'll do one of these pieces right now. I'll put it right on top of the ping. I'm going to ping Google, for instance, and we'll ping and see what answer. Now, Google's DNS is 8.8.8.8. So it's a very easy one for me to remember. I can remember 8.8.8.8. And it's a great one to use to check to see, is the internet still alive? So we were waiting for that Mayan apocalypse to occur. I just sat at my desk and pinged 8.8.8.8. If Google disappeared, what's the point at that point? That's no reason to continue life on Earth, right? So constantly ping that piece. Now on my ping, I got responses to this that said the time to live 45, time to live on IP version 4, which is what we're using here, means how many hops away something is. So I can't really use that from a performance perspective. Maybe I can kind of figure out how far away it is based on the time to live. But it also shows me milliseconds. How long did it take for me to send that response until I got a response back? And I see it took 67.791 milliseconds, 67.285. I even have a fancier one on my machine called MTR, because maybe I would like to combine, I got too many eights. Maybe I would like to combine the idea of every hop along the way and what it's doing along the way with those pieces. So you can get a feel for what was the packet loss. How many have I sent? What was the last value I got? What was my average, my best, my worst, and the standard deviation of those, just to get to 8.8.8.8. Very, very useful to be able to see those pieces as well. So that's one of the things that when you start getting into ICMP, I still don't know at 8.8.8.8 at that device, how much memory is it using? What disk space is available on that device? How much CPU is there? So this gives me an idea of network performance, but ICMP, not so great from understanding real true performance. And if I'm in this case looking for the best choice, you get this all the time on the exam. It asks, what's the best choice for doing this kind of thing? The best choice on this particular question, SNMP. So that was well received by most of you. You guys had no problem finding that one, did you? So that's one that will come up quite often. You have to look for in your exam is find the best choice. That you have to really watch those pieces. A question that came from DW into the list this month is, how much of a security risk is using public Wi-Fi hotspots? Now, for those of you that are studying for your Network Plus exam, obviously wireless networks, the encryption and protection of wireless networks is on there. A lot of the security aspects on the Network Plus certification, you have to know a lot about the security problems you might run into. You have to know about buffer overflows. You have to know about man in the middle. You have to know about database injections. There's so many different pieces to understand that. But when you get into a wireless network, especially a public Wi-Fi hotspot, you might get into a bit of a challenge. So one of the things you'll, of course, notice if you go to a Starbucks or you go to anywhere, that everything you're sending is in the clear. You're not given a password to at least try to encrypt some of this data. Everything that's coming through, absolutely in the clear. So that means if you're communicating in the clear on this wireless network that's in this room, and really outside of the room a little bit, but let's say in the room, anybody who's in there can sniff the air, can grab traffic, protocol decodes right out of the wireless network that's in there and see what information you've sent. If you send a password in the clear, they can see it. If you send email in the clear, they can see it. Everything. This is incredibly common to do on wireless networks. There are some ethics problems there. So if you walk into a coffee shop and you start sniffing the air, is that a good thing or a bad thing? You might want to think about what you're doing there, because there could be some serious problems for you if somebody was to see what you were doing and how you were doing that. Another piece is that now we have a need to be able to encrypt. If I do need to send information out, maybe I need to think about some other methods there. People can see what I'm doing. Another thing that's not commonly done on these wireless networks, and it really should be, and I see this on wired networks as well, is a configuration option called network isolation. This is commonly in wireless access points. You also see it on other network devices. And if you are in a coffee shop and you bring up your iTunes and you see other people's machines in the coffee shop, or you go to your network browser and you see other people's machines that are in your network browser, that's because they've not enabled this ability called network isolation. When network isolation is turned on, you can, on your machine, go to the internet, but you can't communicate with anybody else who might be on that network. because in a wireless network like this, everybody has to go through that wireless access point. And if you can tell a wireless access point, don't let the person sitting at that table communicate with the person at that table, then you won't see anybody. But it's so rare to see this turned on. I travel a lot. I am a million miler on Delta. I go all the time through airports, through hotels, through coffee shops, through Panera Breads, through everywhere. If there's a wireless network, I'm on it. I want to see what's going on. I want to see if they have network isolation turned on. And I want to see what options are available when they do that. Rarely implemented to see that. And now you get into challenges, because if I can communicate to other devices, I can now become a man in the middle. I can potentially have that person send all of their traffic to me before I send it out to the internet, and vice versa, which means now I can really see what's going on with that person's machine. I can change data that's coming back and forth on that person's machine. I can get into encrypted data because I'm sitting in the middle. And that becomes an issue. So what a lot of people will do, and what you should be doing in these environments, is make sure that the personal firewall that's in your operating system is turned on. Make sure that nobody can access anything directly on your machine, because if it's wide open, anybody can talk to it. Also, consider adding a VPN into this mix. You want to make sure that all of the data you send out over the internet is in an encrypted tunnel. Even if they tried to get in the middle, they couldn't. Even if they tried to look at the data, there'd be no way to tell what you were sending. Whether the application is sending the data in the clear or not doesn't matter, because before it leaves your machine, it's encrypted and sent across that encrypted tunnel. VPNs become extremely important there. One of the questions, so do I sniff packets when I go these places? No, I don't. I could. In fact, it would be exceptionally easy to do this. But quite honestly, it doesn't gain me anything. What am I going to do even if I find somebody's email password? Am I going to log into their email? No. I don't have time to bother seeing what they're sending back and forth. Not very useful to have those there. And there are some ethics and in some cases legal problems if you plan on doing that. You have to check in your local area what's involved. Now, what you really don't want to run into is doing this in a place where they are sniffing the network. What if you've gone to DEF CON? What if you go to, and this is at other conferences as well, and you're using an application you're not over a VPN, you're not in the clear. They have something at those conferences called walls of sheep, where they will put up your email address. They will put up a part of the first three letters of your password. They'll put up the IP address and the application that you were using to do this. Oh, you want your Twitter password? I've got it. Here it is. Oh, your mail password for IMAP? I already know what it is. And they just stick you up on the wall, and then everyone gets to laugh at you. The wall of sheep, very common to see. If you go to a security conference, there's a wall of sheep somewhere, whether it's being broadcasted on the wall or whether it's somewhere where there's somebody has set it up on a website that everybody sees, whether they tweet about it, they've got a wall of sheep. You don't want to be on the wall of sheep. When I go to a security conference, I don't use my Wi-Fi ever. And I don't use my wired in the hotel room unless I'm using a VPN. So one of the questions in the chat room is, can I connect to a VPN over wireless? Absolutely. And if you are on a public wireless network, I highly recommend that you consider using a VPN connectivity every time you're on it. There's even some types of VPN software that automatically recognizes that you are on a network connected to the internet, and it just turns on automatically. You don't even have a choice. It just connects up and does that piece of it. So there's a lot of providers out there, not a lot of good free ones. And the questions, how about free VPN? There's not a lot of good free VPN, but there's some very good low-cost VPN. You can pay $5 a month, $10 a month, and you'll have VPN access. Or sometimes you can buy a cable modem that you can configure your cable modem or your router that you're using with your cable connection, or your ISP at your house. It's built into your wireless router, a VPN connection. Usually helps a little bit to have that piece of it. It's very standard. Somebody else in the chat room was asking, what about, I've heard this thing, OpenVPN. You ever hear of that? Yeah, that's an open, not a standard, but an open application that you can download for free, load up on your server, load up on your client, and now you've got a VPN going back and forth. Works great. A lot of the $5 and $10 VPNs that are out there are using OpenVPN as the client you would load on your operating system, because it works off a different operating system to be able to do that. Very, very easy and very open and very standardized. A lot of people use it, and it works great. It's a VPN with encryption. It's not magical to be able to have to do that these days. Question, does VPN slow down your connection? That's a pretty good question. Obviously, if you're doing some type of encryption in your operating system and sending the data out and doing decryption of that on the other side, there's overhead associated with it. Now, ideally, you've got plenty of time, CPU cycles, plenty of overhead on your computer to be able to do this. You rarely see a problem in performance at being able to do that. But now that you're talking to a single device, what if 100 people are talking to that VPN concentrator on the other side? There might be performance problems there. So you have to think about that if you're planning to implement a VPN environment. That's something to do. Well, this group that we're doing, we do this every month, and our Network Plus user group this month is sponsored by our folks at GTS Learning. They're the ones that have freestyle. This is something very different. People aren't used to having this. Usually you're used to going out and you're buying a book and you're buying maybe a set of exam test questions from a third-party site. And maybe you're trying to get some videos that you could watch somewhere else and have all these things, and you have to figure out where they're coming from. They're coming from different places and they don't work together. Well, freestyle. The folks at GTS Learning created freestyle so that you don't have to worry about any of that. Freestyle is a method that you can use, and you can find out more about this at professormesser.com/freestyle. Freestyle is all in one. You go one place, you've got sample exams. You go one place, all of their books, all of their CompTIA certified books are in freestyle. If you want to do a look at videos, videos are integrated into the book. So as you're reading about a topic, my video is right there in the middle of it. And if you got the printed book, you can use a QR code. If it's right there on the screen with freestyle, you can do that piece as well. Very, very useful. I worked with GTS Learning when they were first building this, and they asked, what would we need to be able to make this all in one? What would we need to really make this shine? And it was this freestyle that they finally put together with things that they had in their arsenal, things that they had worked on previous to this. And they have on the freestyle, I'll bring it up so you can see some of these screens of it, their integrated learning. I have the N10005 course right here. So if I wanted to know about addressing and routing, it effectively not only has a prerequisite test and a practice exam, they've got everything that's in the book. So if I wanted to know about DHCP and API-PA, I click on that link and they will show me information. There's one of my videos is part of it. And then all of the text from the book is right there. One place to go. You don't have to worry about getting that from other places. As you're reading, all the information is right there. I think I have a really bad video screen of this, but you can see it's exactly what you would see online. That's the piece to me that makes the difference whenever you're trying to study is don't waste your time going a lot of other places. Go to one place. And in fact, I'll go back one so we can see this piece. And let's take a test. Let's take a practice exam. It's all in the same place. And it says, okay, you got an hour and 30 minutes, just like the real exam. Looks like I started one earlier. Let's go back to it. Okay, here's the question. A user's complained of problems or a new application. You can look in an exhibit. This looks just like the scenario you would have on another exam you're working with. And then you can answer the question and then go to the next one. If you don't get it right, and in my case, let's say I don't get it right, it tells you you submitted this. You didn't even give an answer to this. This is about objective 4.4. Go learn about it. You can go to this unit to view more information, and then at least you know where to go if you don't get it right. That's something you don't get on the exam. You got that wrong on the exam, they don't tell you where it came from. They don't tell you where to go. It's all in one place. So very nice capabilities to be able to have that functionality right there in front of us and be able to go to one-stop shop, if I say it right. To be able to have that all in one place. We appreciate GTS Learning sponsoring what we're doing here. Again, if you want to know more about freestyle, go to professormesser.com/freestyle and you'll learn all about that piece. I'm going to now move into a different section of our monthly study group where you've asked me questions about the exam itself. And this comes up quite a bit when we're looking at questions about the exam, some things that come in a lot. I've also created recently some frequently asked questions videos. So we're going to see a lot of those in the mix as well. But one of the questions I got in that was not part of those frequently asked questions was there are hundreds of networking acronyms. If you go to the CompTIA document, you'll find that they are in there. A+ doesn't really ask you to define any. I don't necessarily agree with that. I think A+ asks that you define a lot of those. You have to know what SATA and PATA and all of those different types are. You have to know what the DIMMs are referring to. So I think it doesn't ask you a lot of the networking piece, I think is where he was going with this question. And then D, there's a much larger section on networking on the 801. I think this question really applied to the A+, that was the older 701 exam. So there's a lot more networking on the A+. The Network Plus certification, lots of acronyms, lots of things you have to know about. What CompTIA has done, though, is they've put them all into the exam requirements document. I mentioned this earlier on in this month's study group. The exam requirements document has everything in there. There are pages and pages and pages of acronyms at the end of the exam requirements document. So if you're not quite certain just exactly what you should know about, they've already listed it out for you. I highly, highly recommend that you go through and look at the exam requirements documents, because sometimes you'll buy one of these books and the books have everything in the world inside of it. They look at a protocol and they dig down into the protocol structure. They try to make you understand what a particular variable within a packet inside of that protocol is doing. But you really don't need to know that for your Network Plus. It's really more of extra information they're giving you just so you can learn about how it works under the surface. But some people don't want all of that. They just want to know, what do I need to know to pass the exam? I'll learn the other things afterwards. I'm on a time crunch here. My boss said I have to have this done in 2 weeks. I don't have time to learn about what bit 1 means or bit 0 means inside of an SMB packet somewhere in a variable. I need to know right now, what do I need to know about SMB? No more, no less. Just tell me exactly what I need. The Network Plus exam tells you exactly what you need. So don't get trapped into these. You'll see these books. They are enormous. You're looking at, wow, people say that's a great book. Well, it's a great book as a reference guide, but it's not a great book if you need to know your exam data and nothing else. So make sure you read through the exam requirements. That way, even if you have the big fat book, you'll be able to match up with what you need to know, and you'll be able to skip over the pieces that don't actually connect up with that piece or mean anything associated with that piece. And this also goes to the other question I got this month, which was, do I prioritize my videos by importance? JA asked this. And I don't prioritize any videos. I don't put them in any particular order. If you go back and look at the exam requirements, you'll notice that every part of the exam requirements are numbered. Section 1.0 is networking concepts. Section 1.1, compare the layers of the OSI and TCP IP models. Section 2, classify how applications, devices, and protocols relate to those OSI model layers. That's how my videos are in order. They're in order by this format. So if you're trying to find information, you're looking through the exam requirements document, you got to a section on IPsec, all you have to do is on that section, figure out what number is associated with that. That's the exact same number on my videos. So no, I do not prioritize my videos. Nothing is more important than anything else. Everything has different levels of information that you'll need to know on the Network Plus exam. That's why when you're looking at my videos, I put them in a particular order based on the exam requirements. I think it's just an easier way to do that. In the past, I put them in order by what I think you should learn first and what I think you should learn second and what I think you should learn third, very much like books do, but it made it very difficult to find things. So these days, everything is listed in the exact format that's provided to you by CompTIA, by Microsoft, and by the other places that you'll see the certifications come from me. So very, very useful to have that there. And when we're looking to figure out where can I find this data, that's where you can find it. Every month I do a link of the moment, things that will help you learn more about networking. And this week we have a pretty good link of the moment. I mentioned earlier on in the study group that there's I have a good way that you can help learn the OSI model. If you're really wanting to get into it and understand what protocols go where on the OSI model, this is the way that I recommend that you do it. And it's to use Wireshark. Wireshark is a protocol analyzer, one that is absolutely free and one that is extremely powerful and indeed very easy to use as well. So if you are just getting into networking, this is a great way to help figure out what's happening under the hood. What do these protocols do as they go across the network? You need to absolutely go to wireshark.org. You need to start Wireshark capturing information from your network card and then do something. Check your mail. Go to Google. View sports scores. Watch a video on YouTube. Capture all of those packets and then start sifting through them to see what's inside of those pieces. It becomes extremely useful because now you can look at exactly what layers are in use, what MAC addresses communicated between each other, what IP addresses communicated between each other, what port numbers were in use. Look at what we just did. We went from OSI layer 2 to OSI layer 3 to OSI layer 4. What application was in use? Was there any type of encryption associated with it? What did the applications say to each other once they knew they could talk across the network? You can see all of that in Wireshark. And when you start doing this as your normal job and you're managing a network, or you're in security, or you're trying to figure out why the database isn't working, or you're trying to wonder how to get better performance out of file transfers to a remote site, Wireshark can answer all of those questions for you. It sees everything. And if you become very good at using a protocol analysis tool, you can answer any question about what's going on the network. It becomes extremely powerful. There's even some nice features within Wireshark that allow you to take an entire flow of traffic and rebuild it. Rebuild the web page that somebody was looking at. Rebuild the voice communication and listen to it that somebody had go back and forth. Take an encrypted link, as long as you have the certificate, apply the certificate, it decrypts it and tells you what was inside of that. Pretty powerful stuff. So that's into the more advanced functionality of Wireshark, but certainly speaks to how powerful that is. And if you're a networking professional or you're trying to be a networking professional, this will help you in more ways than you can ever imagine. You can learn more about that at wireshark.org. Well, there was a lot that we went through on this month's study group, but you can, of course, watch what we do all month long. If you want to see anything that might be going on in the Professor Messer studios, you can always follow us on Twitter, professormesser.com/Twitter. I am, of course, on Google+. You can find me at professormesser.com/Google+. Our YouTube channel, if you ever said, is there anything I can do for you, Professor? Yes, you can go to YouTube and subscribe. You can go to Twitter and follow. Those are great ways to show people that you are interested in what we're doing here. And it's a great way to show YouTube and show Google that you like what we're doing here at Messer Studios as well. Facebook, you can go to Facebook too. Not a big fan of Facebook because Facebook does not show you everything I put there. They only show you what they think you should see. So it's not a great way to follow me, but indeed there's a lot of stuff. If you wanted to ad hoc go out to Facebook, you can find me at professormesser.com/Facebook. Again, thanks to GTS Learning. They have been great for us this year. And again, if you want to know more about Freestyle, go to professormesser.com/freestyle. They've got some free demos that you can try out while you're there. And of course, thanks to all of you. Your questions I get every month are absolutely phenomenal. You guys do a great job at keeping this entire thing going and making sure that we're able to do this every single month. And I really appreciate your help with all of these things and the continued support and messages that you've sent throughout the year. I'm expecting 2013 to be another fantastic year. Well, thanks for joining us this month. We will see you next time on another Professor Messer Network Plus study group.